there's a rising tide of APP scams, and it's been increasing year on year. It's showing no signs of stopping anytime soon. The flip side of APP scams is that for every APP scam victim, we have a network of ready money mules that are ready to receive the proceeds of fraud and scams. And that's the bit that we think that needs more focus if we want to truly solve the problem. So we believe, as part of our solution that we've developed, that we need to combine data from between the sending bank and the receiving bank. And our solution focuses on the development of a real-time prepayment risk score to support decisioning. You'll see on the right-hand side of the slide just a few of the posts which are very prolific on our social media channels and just show how easily money mules are recruited to earn money in a way that they believe is just very quick, very easy money. So I'll hand over now.
Thank you. So if you look at the problem, I think what we see is that it's an unfair game. Yes, it's easy for the mules or the attackers to play these attacks. There's limited consequences. So we think about a way that we can attack the scale of the problem, make it less scalable for the attackers to perpetrate these frauds and for the banks to defend that. What we also see is a lot of the investment and the focus is on the point of payment. So on the victim's account or the victim's behavior, which is just a proxy for an attacker. So we believe that the set of accounts to where the money is going to, that's a candidate for we should look more closer, we should shine a lens on that. And can we identify signals from the beneficiary bank's accounts? Not just at account onboarding, but in near real time, that's information that we can use to make better decisions. So for example, for purchase scams, we think it's much more likely to find some intelligence or clues in the beneficiary account. So our proposal is to look for signals, and use the rails built by confirmation of payee to communicate additional information, which is bank to bank. So currently we do just a name check. There's a potential to exchange additional information about the beneficiary bank in order to come to a better conclusion about the nature of that transaction and if an intervention is required. So that was a hypothesis. So we looked at the data. We looked at Bank One data specifically, and we looked at honest payments within the same bank. We tried to see which ones are marked as fraud, which ones are not, and we did a comparison to see if we could get any early signals. So one of our observations is that the volume of transactions in these so-called Mule accounts is significantly higher. Our early analysis shows 37 times higher. Now, we're surprised by that. We'd want to look closely at that, but that could be a very clear signal. There's other signals, for example, in terms of inbound or outbound payments. Again, Bank One data. We looked at that the genuine transactions had a ratio of 3 payments for every 1 incoming payment. For Mules, it was more 1-to-1. Kind of makes sense, like money coming in, money's going out. There's a signal there. We also looked at incoming payment amounts. This is less of a hard signal, but this is something where we see a discrepancy between these data sets. So I'm going to hand off to Claire. So there are signals that we can use in the beneficiary account. Our plan is to communicate them.
Any questions? Nick?
Hello. I'm just amazed that 37 times more transactions are from Mule accounts on real data. How does that work in terms of a productionized solution? You've got some great analysis there. How would you actually implement that?
I think I could take this one. Yeah. Happy. So I think the insights through the last few days have shown that actually the transactional activity is really, really powerful. But we believe in terms of developing a risk score that we'd look to overlay that with other data, things like CIFAS intelligence, law enforcement intelligence, things like behavioural biometrics, device biometrics. Has the device that the Mule is using, has it interacted with any other accounts that have either received the proceeds of fraud or have been a victim, and how can we tie that together with our existing consortium data around bad devices, bad accounts. So linking it all together to develop a risk score that is then presented to the sending bank, and the sending bank can then decide based on that data, do they want to release the payment, do they want to hold the payment never to make it again, or do they want to have a really good conversation with their customer.
If I could add to that, our intention is to not be in a place where we have to share the data, but share the intelligence and share it in near real time. The hard part is defining the standard for what the standard for this exchange looks like. And I think that's something we'd have to look at, consult, and identify whether we look at risk scores or risk bands as a mechanism to communicate this information.
I think you might have time for one more.
You've identified a really interesting signal. How hard would it be for attackers to recruit 37 times as many mules and therefore hide within the data, not standing out?
So I guess just based on experience, I mean, there are 37 mules for every victim. I would say the industry is full of them, sadly. So there is a real challenge because actually before they receive that money, they don't look suspicious. But it's by combining the fact that there's a high risk payment coming in on an account that looks perfectly normal, but actually if you take into account that payment coming in, you can then form that view that says, hang on, this looks odd, and then do a deeper dive on that account. Are there any linkages, by, as I've said, device, address, email, whatever it might be.
One of the other things is that that's just one signal, and of course this could be supported by others. But fundamentally, it's aligned to our approach. We attack the scalability of the attack. Yes, so we've shaved off this attack surface at least a number of mules by 37 times. That's also a contributing factor into the overall volume of attacks that we'd see.
Okay, thank you very much, APP Trappers.
Thank you very much.